fellow programming engineers. Welcome back once more to this drive course. And today we're going to be analyzing our digital outputs in our components. So we already analyzed our digital input and how to assign the different function and different tasks for each one of these. So the same thing happens with our digital outputs, which I think you're already getting an idea. So if you could do it like this in our inputs, then now we're able to do it in our output. But now, why would I want to assign outputs if basically our motor is already ready? So why am I interested in getting an output? They have many different functions for all these outputs. But I'm going to be completely honest with you. The main goal or the main activity, really, is to indicate that my motor is being started up, or to indicate that my motor is down, that we're not assigning any sort of frequency. That is the main activity, okay? So they have a lot of multifunctions. For example, when they detect the PID is wrong or that it has a problem or something. But this is already set for more specific activities, which we're going to be checking into a little bit more detail further down. However, for now, remember that we are going into these activities which are essential so that we could basically start any drive we want. Okay, so this type of buttons, okay, these are input buttons. But there are many combination buttons, and this is a luminous connection, which basically they look like this. So when we press our button, it's going to run a function in our digital input. But it has an LED light, and this is how it generally looks, together with its contact. Now, this is optional, but anyways, it has a regularly open contact. However, it seems it has a contact, but remember that this is an output. So remember that this is on hold for getting voltage. So we need to review and analyze what type of voltage can it take. Now, that's a different topic, but I'd like to point this out to you so that you guys can see. In case that you need this, or in case that you need to do this, if it really works, we need to indicate when we press this button and it's being started up, that it lights up a green in this case. Okay? Now, this button, it seems to be flat, but it should be transparent, and this is a stop button. But in case I'm pressing this, or in case this is pressed and that I already removed the start button, and now it only wants either zero frequency, or if it's down, that it lights up, indicating that there's no motion in my motor. Okay? Now, another essential activity is to detect any failures, or that I detect that something has been presented in my drive. So in this case, it might be a beacon light, which in this case is used to indicate an alarm. Okay, which means that something is wrong, that there was an error or something. Now, this is for more complex applications that basically shouldn't even exist for any type of flow on the line, any kind. Okay, so this is how their digital outputs work. So now we're going to analyze, with the help of our manual, what this means. Okay, so here is our page number 245. So generally, where our digital input is being indicated for our multifunction, it should indicate, lower or below our outputs. So in this case, these are our H2 parameters, H201. Okay? Now here, we can select, which one do you want? I want our function terminal selection, MA, MB, and MC. What do you need it to have? In this case, well, what do you need it to do? So this is where we can say, what is it going to do? So we're going to run our diagram. And, well, how does this look now? So this is basically like a relay. This works as a relay, actually. If you remember how this works, we have a common activation. And depending on the coil activation, means that if what I have as a common voltage, that it goes to my carrier. So if it's regularly open, then the coil, if it's not being activated, then what it is doing in our common is going to go to our regularly open one. Okay? Now, what is regularly open is logically not going to transmit the voltage. Now, if the coil is activated, what was set as regularly closed is going to open up, and now it's going to allow the energy flow. The energy flow where it was regularly open. Now, this is what happens with a relay. How does it work here? It's basically the same thing. However, it's going to change between contacts, depending on the function that we added. Now, beware, it's not going to assign any voltage. So you need to be very careful with this. So if it says here, well, it takes up to 250 volts for AC, or it can take 30 volts for DC, sorry. Then it's going to assign that voltage, right? No, it only supports this. But what am I going to run correctly with my connection? So I have my lamp here, right? If you notice here, we have X1 and X2. Yeah? So I have my lamp here, my little lamp. So I need it for it to start. Let's imagine that I wish to light on my lamp or power on my lamp. So we're going to remove the drive. So I need to add here a voltage, whether it's a positive and a negative. It all depends. Why does it depend? In case this lamp works with DC. If it's DC, it needs a positive and a negative. So I need to locate from this lamp what is my positive, what is my negative. And from there, I need to close my circuit with this contact, with these contacts actually. So if it's a VCA or an alternate current, then in this case, what's going to happen? Well, generally, if it's 110 volts, I need to place where it's asking me to connect my neutral, and on the other side, my phase. So if this is double phased, if it's 120 volts or 120 VCA, it basically doesn't matter where you connect it if it's double phased. So this is 110, and as well as on this side. So depending on the configuration for the lamp. Okay? Now, what is it that you guys wish to interrupt? Do you wish to interrupt the phase? Or do you wish to interrupt a neutral, the negative part, or for the positive part? Now, what you guys need to do is you need to interrupt something. Okay? Because thanks to this interruption, we're going to be able to control that lamp or that output. Now, let's suppose that on one end, I'm going to connect it to one phase. And on the other side, so that the circuit closes and that it closes lamp, I would need to connect it to a neutral, which is 110 VCA. So now, our phase I'm going to connect in DC. But my neutral is the one that I'm going to connect over on this side. Okay? So I'm going to take my neutral directly and I'm going to connect it to my MC, which is my common. So then internally, and thanks to this diagram that I have here, it's going to tell me that my MA is my regularly open one. And my MB is the regularly closed or normally closed, which is what I am able to see here in this diagram. Now, if I add the parameter and I configure this so that it is activated, and when my motor is starting up and this other lamp on the other side that is neutral, I'm going to connect it here only. So by the time it's being started, then now the energy on this side is not moving. So that it only needs to change here, and so therefore the neutral circuit is going to be closed out. It's going to be MC, it's going to move on through this side, and this is what's going to give me the neutral that I need so that the circuit closes. And that way, my lamp is going to power on. Okay? Any questions on this side? This is pretty easy, guys. Now, I've seen certain cases where engineers get confused on this side and they burn out their drive. Only on this side, okay? So you need to be very careful, guys. I've seen certain cases, really I have. And it's normal, it's something regular. This is what happens because we're all learning together. No one knows absolutely everything right from birth. So this can create a very insecurity issue. So this is why I'm telling you this. This is why I'm explaining you this. So that you don't go through that. Or if something like this already happened to you, you do not need to be scared, and we all need to analyze this. It's not the same thing that if I see this in a manual or anyone else that has already seen this needs to tell you about this. Now, I've seen it. I've lived it. We all make mistakes, and it's perfectly normal. But you need to be very careful, but because this is where it smarts. This is where it hurts. Now, what do we mean by this hurts? Because it connects on one side our feed, let's say our MC phase, and as they say, well, this is the regular. I either connect the neutral or the phase. Or no. You know, what should I do? So I'm going to connect the neutral here. So then that's where they make mistakes. That's where they regret it and they connect it. So that's where some people say, well, this is where I'm going to get the voltage in theory. But people don't know how it's working and they're not analyzing this. Now here is where we're going to connect our voltage. And what do you think is going to happen when we connect our drive? If we have our neutral here and we have our voltage here, we're going to start our drive and it's going to short circuit here. It's going to short out here. Okay, that's where it's going to explode on this side. If it's not protected on the drive band, then it's basically going to burn out many different circuits, and it would be need to swap out. So it's all about playing with the interruption, either of one phase or the neutral. Now, this is going to depend on what is more feasible, what is an option as a rule. So we need to be very careful with this. It's going to depend on if you wish to interrupt the phase or the neutral. Or in this case, if it's 220, then in this case it needs to be one phase. Okay? All right. Now, how does this work? I think it's 248. And here we go. So we, on this side, we decided, and we have to select our selection terminal, which in this case is not an output per output, because this is only for assigned ones. For these outputs, which in this case for Yaskawa is MA, MB, and MC. Now this is what tells us that this is a relay. However, there are other things that these are selection for terminal P1 and P2. Now you guys need to help me by checking with our simulator where you think this belongs or this matches. So it's indicating us P1 and P2, which is basically this. Okay? Now I recommend that we use this because this is actually a relay output. This is actually a photo coupling. Okay? So then I recommend, if you guys are pretty simple, I recommend that you use your MA, MB terminals or MC ones, or basically the ones that say relay. So these are the good ones so that you guys can run your configurations. The other ones are a little bit more, specialized because they're couplings. So you need to be very careful, guys. And once we have it selected here, it says, well, you need to head to the H2 configuration for the multifunctional digital output on page number 247 for its configuration values. So what are we going to configure here? The most common ones are during production or during function. So when it's closed, the advance or the run command is going to be active, and it's going to come out to the voltage output, which means that the regularly open or normally open is going to be closed, and it's going to allow for the flow for what we have connected in our common as such. Okay? So velocity 0 means that the frequency, the output frequency is going to equal 0. So when this equals 0, it's going to run this change, which is basically the same for contact. And there's many other things that we can start configuring, but these are more specific things. Whenever there's a flaw, as I was telling you on this side, is when we will be able to connect an alarm. Okay? And these are more specialized things, but if it's for frequency, whether we want to use it or not, and here we also have an alarm. Actually here, these are failures that are somewhat specialized in the drive. So we can locate specific failures. Or basically, the alarm, this is where the part is coming through. Okay? So when something happens here is when we send out an alarm as such for our drive. So these are alarms, and something completely different are failures. So when we have an alarm, we can connect the device, which indicates us that there's an alarm that is present. Okay? So the timing or the timer output, you need to analyze and review in case in the future you need to use this. If not, don't worry guys, we're going to go to the most basic part. So basically, And honestly, these parameters are not very used, to be honest. So we have the PID feedback, and these are very specific things. So don't worry, guys. Don't worry about memorizing this. But check to see what your drive can do and what this drive can do. But aside from this, you're basically not going to use this unless it's something very, very specific. Now, how do these work next to our very famous simulators? As we can see for Yaskawa, we go here, it's all working correctly, and we run, and our drive is working. But now, what would happen if I want to assign its voltage connection to our lamp in this case? So what I wanted to light this up. What is it that we would need? So let's practice this, guys. So I select my parameter H201. So we head out to parameters and we head out to H, letter H. So these are the H's, and here we have our inputs, but I want my output, which are H2. Okay, so it says terminals MA, MB, and MC. So we select this, and here, by default, it is set as 00E. So apparently this is not set up. So I want to set it up so that it works whenever it's started or whenever my motor is started. Okay, so let's stop this. If I start this, it's not going to light up. Okay, so enter. And in this case, all we need to do is we need to add it as 0. Okay, so that it's set up as 0 on the other side. So we go down for 9, 8, here we go, 0, 0, 0. Here we go. So let's see what it does. Let's see if this works. So we're going to start this up, and now it's assigning me that voltage. From MC, it's sending it out to MA. So then what is sending out for my MC, which is what we have connected here, and what is being sent out on this side is to close out our circuit. So we're going to feed it on this side, and this is going to be connected directly. Okay, so this is how it works. Okay, if it's in 0, it doesn't matter because we still have our startup command or our run command. Now, what do I want you guys to do as a practice, and something basically as simple as this? I'd like that for our same terminal H201, I wish that you enter the 0 for parameter and see how it works. And here, start practicing with other parameters so that you guys can see how easy it is to run this configuration, because in reality, this is what I've been saying. Many engineers, what has happened is they've had bad experience on this side with our outputs, and they don't want to go near their drive because they might burn it off. So the same way that it's easy and simple to run controlled connections, and it's something very, very simple for our connections with our motor and everything else, we also get overconfident, and that's where we make mistakes. And that's where we start burning our drive. So you need to be very careful on this side. So basically, these are the outputs and how they work. So if we stop these, it's not going to send out anything else. Okay? Now, which one is activated? The regularly open one. That's MC. And here, it's going to send out voltage. So if you have nothing connected here, don't worry, guys. There's nothing for you to worry about. Okay? If you have any questions or any comments, please let me know in the comment section. And with this, we're going to move on to our next video, guys. Thank you very much, and I'll see you guys on our next class.